Okay, in this video, you're going to practice graphing systems of equations and identifying the solution. So the first equation we're going to graph is y is greater than x minus 2. So you graph just like a linear equation. You want to recognize that the 1 is your slope. It tells you you're going to move up 1, right 1. Minus 2 is b, the y-intercept. So we're going to start at -2. And plot our point. Then we're going to move up 1, right 1, up 1, right 1, up 1, right 1. And then to graph this inequality, we want to ask ourselves, is this a solid or dashed line? It's a solid line. So we're going to connect our points, and then we want to shade, either above or below. Well, this is greater than, so we're going to shade above. So if we're going to shade above, we're going to ask ourselves, where are the values that are greater than -2? They're above. So above on the y-axis is here. So if you shade everything above, it will be in this region. The second equation, y is greater than -x minus 2. Negative x, m is -1, the slope, down 1, over 1, -2 is b, the y-intercept. So I'm going to start at -2 on the y-intercept, but this time I'm going to move down 1, right 1, down 1, right 1, plot a point. In the opposite direction, I'll go up 1, left 1, up 1, left 1. This time I have a greater than symbol, so I know this is going to be a dashed line. Dashed line. Now I need to figure out where do I need to shade. I'm going to shade greater than -2 on the y-axis. All the values that are greater than above -2 are up here. So I'm going to shade this region. So what that means is everything in the crosshairs of these two lines, of these shaded area, will be a solution. So it's only this shaded area above here, anything that falls within this region will be a solution to this system of inequalities. It cannot be anything that falls on the solid line because it would be true for a solid line and not the dashed line. So it cannot be this point of intersection here. It's not true for both equations. Anything that falls on a solid line is true, but not on a dashed line. So it would have to be both on a solid and dashed line. So here you can say that your solution's at 0, 0. So here's some examples of a solution. Anything within the shaded area. So 0, 0, let's say -1, 2, +1, 3, anything in the shaded area. Something that's not a solution would be anything in this blue area. So 3, -1, or -2, -2. It has to lie within the overlapping shaded area. In the next example, we have y's less than -2, x plus 4. So -2 is my slope, and it means I'm moving down 2, right 1. B is 4, my y-intercept. So I'm starting at +4 on the y, and I'm going to move down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. So next I need to ask myself, is this a solid or dashed line? This is going to be a dashed line, so I'm going to draw a dashed line. Now I'm going to ask myself, where am I going to shade? If this is less than, I need to either shade below or above. Well, anything less than +4 is below, so I'm going to shade below. All of this area below. Now to graph y is greater than -1/3 x minus 1. I'm going to use the slope to move, -1/3, so I'm going down 1, right 3. B is a y-intercept. My starting point's at -1. So put your point at -1 and move down 1, right 1, 2, 3. In the opposite direction, up 1, left 1, 2, 3. Now Again, this is a greater than symbol, so I'm going to have a dashed line. And now to shade, it says greater than. So I'm going to ask myself, where are the values greater than -1? Are they above or are they below? All the values that are greater than -1 are above. So I'm going to shade everything in this area. So I'm going to shade above would be this way. Anything above here. So the area where they overlap is going to be over here in this section. So anything that falls within this shaded area where they overlap is a solution. So examples of the solution for this problem. It would lie at the origin, 0, 0, or you can say -1, +4, -1, +4. You can say -3, +1. Something that's not a solution would lie in either something that falls outside of that area. So -1, -3, or +3, +2. If it's on the outside, it's not in the shaded area. Okay, I'm going to move on to my next example. In this example, you have y is less than 3. When you graph an equation with y and a value, you want to go back and remember Hoy Bucks. Horizontal lines have 0 slopes and they are y equals a number. Here, my slope is 0, and b, the y-intercept, is at 3. So I'm going to plot my point at 3. If my slope is 0, this is a horizontal line. So I need to go back and identify, is it going to be a solid or dashed? Well, because it's a less than symbol, it's going to be a dashed line. Dashed line. And then I'm going to shade everything that's below 3, everything less than 3. So that's below here. Everything less than 3 is below. Now to graph the second equation, I'm going to use the slope, -1/2, and move down 1 right 2, and use b, the y-intercept, at -1 to begin on the graph. So I'm going to plot my point at -1 and move down 1 right 2, down 1 right 2, opposites up 1 left 2, up 1 left 2. Now this time I'm going to have a solid line because it's an equal to symbol. So since it's greater than or equal to, I'm going to ask myself, where are the values greater than or equal to -1? They are above. So I'm going to shade everything in this area. So when I look at the graph, anything that lies within this shaded region overlaps both of the solutions, so it would be a solution in this shaded region. So 0, 0, 1, 1, 3, 2, anything within this shaded area is a solution. This area is a solution. Okay, I'm going to move on to my next example. In my next example, I have 3 lines graphed. And this is a dashed line, and this is a solid line, and this is a solid line. So when I look at the point, -2 is here, +1, I want to ask myself, is -2, +1 a solution to this system of equations? No, -2, +1 lies on a dashed line. If it lies on a dashed line, it is not a solution, so not a solution. If it were to lie within the shaded region, 0, 0 would be a solution. Or -1, 2 would be a solution. Only in that shaded region. Okay? And lastly, I'm going to go ahead and go through an example where you have a point and you're given 2 inequalities and you need to identify whether the ordered pair is a solution. So you want to go back and recall. Just like equations, you're going to substitute in that point. So for this equation, if I substitute in 1 for x, minus 2 times 2 for y is less than 1. So 3 minus 4 is less than 1. 3 minus 4 is negative 1. Negative 1 is less than 1. That's true. We need to make sure it's true for the other inequality. So I'm going to substitute in 1 plus 3, substitute in a 2, greater than or equal to 5. Simplify. 1 plus 3 times 2 is 6, is greater than 5, greater than or equal to 5. 1 plus 6 is 7. 7 is greater than or equal to 5. That is also a true statement. So when both inequalities are true for that point, 1, 2 is a solution. Now you're going to go ahead and practice on your own.